Hello everyone. This is the second lecture on polymer. In previous lecture, I discussed what is polymer, what are the different types of polymer. For example, linear polymer, branch polymer, cross-linking network polymer. Also, I discussed different types of polymer based on their intermolecular force. For example, thermoplastic, thermosets, fiber, elastomer, and also I discussed different type of polymer based on their source like natural polymer, synthetic polymer, semi-synthetic polymer. I also discussed in my previous lecture the nomenclature of polymer based on structure and based on source. Okay, and also I discussed that some definition of what is monomer, what is polymerization reaction, what is degree of polymerization. Okay, so all those things I have discussed in my previous lecture. In this lecture, I will discuss on the stereochemistry of polymer, stereochemistry of polymer or tacticity. After that, I will discuss different types of polymerization reaction, addition polymerization reaction, condensation polymerization reaction. I will also talk about in this lecture about on mechanism of polymerization reaction, free radical mechanism, ionic mechanism, coordination mechanism, and then I will talk about some examples of condensation polymer, examples of addition polymer, and also examples of rubber, synthetic rubber, natural rubber. Okay, all these things we will discuss in this lecture. So please listen this lecture carefully. It will helpful for the exam as well as for your engineering subject. Okay, so first one, what is stereochemistry? Okay, so not only the skeletal structure, chemical composition of the repeating unit, but the molecular microstructure strongly influence the properties of polymer. Molecular microstructure means, so in polymer we have repeating monomer unit. Now, let's say first monomer unit has some chirality, let's say R chirality. Second monomer unit also may have R chirality or S chirality, right? The second monomer unit have R chirality in one polymer. In another polymer, let's say second monomer unit have S chirality. So between these two polymer, what is the difference? One polymer has R configuration, another polymer has RS like configuration, right? So depending on this microstructure, properties of polymer will change, right? So various geometric and configuration arrangement of atoms in the repeating unit and the distribution of this spatial arrangement of the repeating unit along the chain are particular importance. So now that this word tacticity it describe the stereochemistry of polymer. Tacticity is the arrangement of pendant group. What is pendant group? Pendant group group is the group of atom which is attached at the backbone chain of the polymer. Means if I see, let's say this is one polymer, these are the, let's say, three polymer molecule. Now this is the backbone of the polymer. Now in the backbone there is a monomer unit. This is right. Let's say this orange color, this one, and this green color. This total is in monomer unit. This is also another monomer unit. Now we can see that in this arrangement, all these monomer unit have same configuration, right? Because all this orange color in this side, left side, and all this green color in the right side, right? We can, if we right. But in another arrangement, you can see there's an alternative. Green color left side, in the next unit, green color right side. Next unit again green color left side. And in the third arrangement, we can see there is random arrangement. There is no specific sequence, green or specific sequence of green or red. It is specific, it is random arrangement of this orange and green balls, right? Now, this is called actually tacticity, means the relative stereochemistry of adjacent chiral center within the macromolecular polymer molecule. So when the chirality is same, right? That is called isotactic polymer. In isotactic polymer, all substituents are present on the same side of the macromolecular backbone, means same configuration in the same side. In syndiotactic, there will be alternative. Syndiotactic, there will be alternative position, and or atactic polymer, there will be random arrangement. Now, what are the example? Example of isotactic polymer is polypropylene, which is formed by Grignard catalytic reaction. This is called isotactic polymer. Isotactic polymer generally semi-crystalline. Syndiotactic, this polymer example is gutta-percha. Is an example of syndiotactic polymer. They are crystalline. And atactic polymer, they will be amorphous. There is no arrangement. There is no specific arrangement of the group, so it will be amorphous. Okay. Example is polyvinyl chloride. So basically, tacticity is the relative stereochemistry of this repeating unit. If the stereochemistry is same, right, called isotactic, in same group in the same site. If the stereochemistry is alternative, called syndiotactic. If the stereochemistry is random, it's called atactic. Okay, this is the tacticity. Now we will discuss the type of polymerization reaction. Now, polymerization reaction means monomer units are attaching with each other. Now, depending on the monomer unit, there is a two type of polymerization reaction. When two different monomer units are attached, and when different monomer units are attached, and attachment involved some reaction where small molecule like water and HCl is removed, it is called condensation reaction. So condensation reaction or condensation polymerization is the polymerization reaction where water molecule, HCl, hydrogen chloride molecule are eliminated during the reaction. That is called condensation polymerization reaction. Another one is addition polymerization reaction where no such molecule actually eliminated from the reaction. In addition polymerization reaction, monomer unit are attached with each other. Okay, and after this, so when this polymer, addition polymer formed, in addition polymer, the number of molecule, the number of atom present in the repeating unit is same like it's same with the same number of molecule present in our monomer starting monomer molecule. But in condensation polymer, since water molecule is still molecule is eliminated, so number of atoms present in the repeating unit is less than the number of atoms present in the starting monomer molecule. Okay, so this is the difference between condensation polymer and addition polymer or at reaction. Now, condensation polymerization reaction is called step growth polymerization reaction, and addition polymerization reaction is called chain growth polymerization reaction. Now, this table discuss the difference between addition polymerization and condensation polymerization. In addition polymerization, we can see the involved monomer contains unsaturated group, means double bond or triple bond. In condensation polymerization, it, the involved monomer unit must be bifunctional or trifunctional, means it will have group like 2COOH group or 2NH2 group like that. In addition polymerization reaction, there is an elimination of small molecule like water, HCl, methanol. But in condensation polymerization reaction, in addition polymerization reaction, there will be no elimination of small molecule like water, ethanol, HCl. But in condensation polymerization, there will be elimination of small molecule like water, methanol, HCl like that. Okay. So in addition polymer form, it has identical same number of atom compared to the monomer unit which is reacted. In condensation polymer, there will be less number of atoms than the monomer unit reacted. Addition polymerization is called chain growth polymerization, and condensation polymerization is called step growth polymerization. The formed product in addition polymer, the, the, the product which is formed in addition polymerization is called addition polymer. The product formed in condensation polymerization reaction is called condensation polymer, okay, or sometimes it is called also copolymer. Okay. Example is polyethylene, which is formed from ethylene molecule. It's an example of addition polymerization reaction. Nylon 66, which is formed from adipic acid, reaction between adipic acid and hexamethylene diamine, the example of condensation polymerization reaction. Okay, so what we have learned still now? We have learned, first we have learned the tacticity, means stereochemistry of polymer. There are three different stereochemistry: isotactic, syn-diatactic, and atactic. Then we discussed about two different type of polymerization reaction: addition and condensation. Next one, this is some example of another example of condensation polymerization reaction. Two different monomer units are involved. There is one more type of polymerization reaction which is called copolymerization, where two different type of monomer unit is involved. But this is not condensation. This is a type of addition polymerization. Why? Because we can see here monomer unit are attached without elimination of small molecule like water, ethanol, methanol, HCl. So copolymerization is a type of addition polymerization reaction where different monomer unit are attached through polymerization reaction, and in the polymer total number of atoms and the number of atoms present in the starting monomer unit also will be same, right? There will be no elimination of small molecules like water, HCl, methanol. So this is the called copolymerization reaction. So polymerization reaction basically two type. One is addition and condensation. And addition polymerization reaction can be called copolymerization when different monomer unit are involved. So copolymerization is a type of addition polymerization reaction. Okay, now we'll discuss the mechanism of addition polymerization reaction mechanism. There are three different type of mechanism: free radical polymerization, ionic polymerization. In ionic there is two type: cationic and anionic, and coordination polymerization reaction. So first we'll discuss free radical polymerization. In free radical polymerization, we need some starting molecule, we need some peroxide that will give us a radical. So here this is an example of benzoyl peroxide. On heating, it will give benzoyl radical. So this radical will react with monomer and then it will start this polymerization reaction. So all this mechanism, it involves three steps. First one, initiation step. Second one, propagation step, where propagation step involves the formation of the polymer, and last one, termination step, to stop the polymerization reaction. Okay. Now in the first step, we are using radical to start the polymerization reaction. So that is called, it is called free radical polymerization reaction. Next one, ionic polymerization, will use some cation to start the polymerization reaction. If we use cation, it will be called cationic mechanism or cationic polymerization. If we use anion in the initiation step, it will be called anionic polymerization. Okay. Here also we can see there are three steps: initiation step, propagation step, and termination step. Now here in the initiation step, if we are using cations, because of that it is called cationic polymerization. In anionic polymerization, we are using anion. So this is called ionic mechanism of polymerization reaction. Third one is called coordination polymerization reaction. Here we have to use some catalyst in the initiation step to start the polymerization reaction. So one important catalyst is Ziegler-Natta catalyst. This Ziegler-Natta catalyst, it is actually titanium uh, TiCl4, tetrachlorotitanium. So when we are using this catalyst, heterogeneous phase, right? So this we are using catalyst, then this coordination polymerization reaction, then it will be called coordination polymerization reaction, because this alkene molecule means double bond coordinated with the catalyst. Because of that, it is called catalytic or coordination polymerization reaction. Okay, so these are the three important mechanism of polymerization reaction. Okay, now we have to give the example of polymer. First, we will give example of addition polymer. In addition polymer, we will discuss these three important polymer: polypropylene, polystyrene, sorry, PVC, and Teflon. Four important polymer. So, what is addition polymer? We have seen that addition polymer means there will be alkene molecule, double bond, unsaturated molecule. After polymerization reaction, it will form a big macromolecule, the polymer molecule. So polypropylene, polypropylene, from this name we can understand that it is the polymer of propylene molecule. So we have to take propylene molecule, we have to perform the polymerization reaction. Now to perform the polymerization reaction, it is Ziegler-Natta catalyst is used. So the mechanism is coordination polymerization reaction. So using this coordination polymerization reaction, we are getting this polypropylene molecule. Okay, so there is the properties and use of this polypropylene. We have to read these things. Okay. Next one is polyvinyl chloride. So vinyl chloride, first we have to prepare polyvinyl chloride. We have to first prepare the vinyl chloride. So what is vinyl chloride? Vinyl chloride means CH2 double bond CHCl, it is called vinyl chloride. So if we take acetylene molecule and react with HCl in presence of mercury, HgCl, mercurous chloride. If we take acetylene molecule and react with HCl in presence of mercurous chloride, then it will form vinyl chloride. Now, if we use this vinyl chloride in the polymerization reaction, we will get polyvinyl chloride, PVC. Okay, this polyvinyl chloride, it is resistant to water, light, and oxygen. Okay, so polyvinyl chloride PVC is used in plastic. Okay, so most important is the reaction. So remember that polyvinyl chloride, from this name we can understand that this is the polymers which can be prepared from vinyl chloride. So first we have to prepare the vinyl chloride. Vinyl chloride can be prepared by acetylene reaction between acetylene and HCl, presence of mercurous chloride. Now if we perform polymerization reaction of vinyl chloride, we will get polyvinyl chloride PVC. Next one is polystyrene. So polystyrene, so name is styrene. So we know this is the styrene molecule, phenyl CH double bond CH2. This is the styrene molecule. So if polystyrene molecule means if we take styrene molecule and perform radical polymerization reaction with benzoyl peroxide, so we'll get this polystyrene, right? Same addition polymerization reaction. And last one is the Teflon, tetrafluoroethylene, right? Tetrafluoroethylene, Teflon. Teflon, so we have starting molecule is tetrafluoroethylene. If we perform polymerization reaction, here we have to use persulfate as an initiator for polymerization reaction. We'll get this polyethylene, polytetrafluoroethylene or Teflon. Okay, so these are the, you have to read the properties and used of all these polymers. So in addition polymerization, we discussed four type of polymer, four important polymer. One is polypropylene, polyvinyl chloride, polystyrene, and Teflon. There is one more polymer that is called polyethylene, PE. Now polyethylene, it has two types. One is low density polyethylene, LDPE. Another is high density polyethylene, that is HDPE. Okay. So what is the difference? Low density. So when polyethylene is formed, prepared, there can be possible two type of polyethylene. One is branch polyethylene, another is linear polyethylene. When it is branch polyethylene, then two polyethylene unit cannot come too close to each other because of steric repulsion between these branches. Then it will form less dense, higher volume polymer, that is called low density polyethylene. When polyethylene is a linear chain is forming, then two branches, two polymer unit can come to close each other. So it is forming high dense and less volume polymer. So this is the difference. So HDPE, high density polyethylene, LDPE is called low density polyethylene. Okay, so polyethylene is also prepared by addition polymerization reaction. It has two types, low density and high density polyethylene. Okay. Next, we'll discuss the different type of condensation polymerization. In condensation polymerization, we have to discuss about this nylon, then PET, polyurethanes, and synthetic rubber. Okay. First one is nylon. Nylon is a fiber. Okay, we first lecture we discussed uh, different type of polymer based on intermolecular force. There I told that elastic polymer is there where less intermolecular force. Little more intermolecular force is present in plastic. Then little more is present in fiber and thermoset and more intermolecular force. So nylon, it is a one type of fiber. Fiber is a polymer. So now in nylon there are different type of nylons. One is nylon 66, nylon 6 and nylon 610. So why this, what is this numbers? Actually if we see nylon 66, nylon 66 means this one. If we started the reaction between uh, hexamethylene diamine, right, CH2 whole 6 NH2 NH hexamethylene diamine, and adipic acid. Adipic acid is CH2 whole 4 and there is COOH. So in adipic acid, okay, so in adipic acid total number of carbon is 6 and hexamethylene diamine total number of carbon is 6. So when these two monomer unit react, we are forming this unit, that NHCH2 whole 6 NH C double bonded of CH2 whole 4 C double bonded. Okay, so now in this repeating unit, you can see there is a 6 number of carbon coming from this molecule, one monomer molecule. There is another 6 number of carbon coming from the second monomer molecule. Because of that, it is called nylon 6,6. In nylon 610, in nylon 610, one monomer molecule is hexamethylene diamine, but another monomer molecule is sevacockyl chloride. In this monomer unit, you can see there is a 10 number of carbon, CH2 whole 8, C double bonded, C double bonded O. So 10 number of carbon is present. So there is a 6 number, there is a 10 number. So total, so this nylon is called 610 nylon. Another nylon is this nylon 6, where it started is a single monomer molecule that is called caprolactam. In caprolactam, you can see NH2 is present, CH2 whole 5, C double bond 2. So total number of carbon is 6. So total number of, since total number of carbon is 6 in the starting monomer unit, so this is called nylon 6. So this part is important for MCQ questions. Okay, so remember that caprolactam is the monomer unit for nylon 6. Sevacockyl chloride is the monomer unit for nylon 610. Okay, this is the important for MCQ questions. Okay, this is, so nylon is a one type of condensation polymer. Why? Because in this reaction, for example, in nylon 6,6, water molecule is actually removed. In nylon 6,10, HCl molecule is removed, right? Since some small molecule is eliminated during the reaction, it is called condensation polymerization reaction. Next one is PET. PET means polyethylene right? Polyethylene terephthalate, polyethylene terephthalate. So this is called terephthalic acid. Okay, so this is called terephthalic acid. C double one benzene ring, phenyl ring, C double H, C double H, 1,4 dicarboxylic benzene. So it is called terephthalic acid. When we react this terephthalic acid with ethylene glycol, we'll call in condensation polymer called polyethylene terephthalate. Okay, so this COOH group react with this OH, one ester is forming, there is another ester is forming. So polyethylene terephthalate, this is called condensation polymer. Next one is polyurethane, PU or PUR. Polyurethane. In polyurethane, our starting molecule is toluene. This is toluene 1,2,4-diamine. Okay, so first we have to take toluene 2,4-diamine reacting with COCl2. We'll get this isocyanate. Okay, this NH2 group react with COCl2, it's forming isocyanate. Another molecule, it is called oxypropylene. So when oxypropylene react with OH minus, it is forming polyoxypropylene glycol. Now this polyoxypropylene glycol and 2,4-toluene diisocyanate react with getting this polyurethane molecule. Polyurethane is an example of thermosetting polymer. Okay. In addition polymerization, whatever the polymer we discussed, there is polypropylene, polystyrene, Teflon, those are actually thermoplastic polymer. Nylon 66, it is a fiber molecule. Okay. Natural rubber, when we discuss, it is a elastic molecule. And this polyurethane, it is an thermosetting polymer molecule. Thermosetting means if we heat this polymer, there will be much more close linking and it will become much more solidified, much more rigid material will be formed. So this is called polyurethane. Now we are coming to the rubber. Rubber is an example of elastic polymer. Now in elastic polymer, now in natural rubber actually we are getting from latex of various trees. Now in this latex, this isoprene molecule is present. It is called isoprene. Isoprene means C5H8. Okay, 1, 2, 3, 4, 5. C5H isoprene molecule is present. So in natural rubber, there is a presented polyisoprene. Okay. Now, but natural rubber has some limitation. Limitation means natural rubber can be easily attacked by alkali molecule. It can be easily oxidized. It can be easily degraded by acid molecule. Right. So these are the limitation of natural rubber. Now to remove this limitation, there is a process called vulcanization of rubber. Okay. So to remove this limitation, there is a process called vulcanization of rubber. What is this? In this process, the natural rubber actually heated with sulfur. Okay. Now we can use different type of sulfur, different percentage of sulfur. If we use less percentage of sulfur, the rubber will be less vulcanized. If we use more percentage of sulfur, rubber will be much more vulcanized. Now the amount of the sulfur is depends on our purpose. If we need more, if we need some synthetic rubber or vulcanized rubber with less elasticity, we can use the sulfur content. We can use the percentage of sulfur. Means if we increase the sulfur percentage, the elasticity will be less. If we use less percentage of sulfur, there will be elasticity. Some elasticity will be there if we use less percentage of sulfur. So natural rubber is elastic, but when we perform this vulcanization process, the elasticity of the rubber is changed. Right now, depending on our purpose, we can make different type of rubber. We can use different amount of sulfur, if different percentage of sulfur, to get different type of vulcanized rubber. Right. So what is the difference? So raw rubber is a very high elasticity, vulcanized rubber low level of elasticity. Now let's say depends on the percentage of the sulfur. quality, if we see the quality, raw rubber is an inherent quality, and vulcanized rubber, this quality can be controlled based on the reaction. Durability, normal rubber is a very low temperature. If we see natural rubber at very low temperature, it will be brittle, it can be breakable. Okay, and at high temperature it can be melted. But in vulcanized rubber, it is stable at low temperature as well as high temperature. Chemical resistant, if we talk about, so natural rubber is not chemically resistant. It can be melted in chemical, but vulcanized rubber is chemically stable. Tensile state is increased in vulcanized rubber. Okay, so these are the properties of vulcanized rubber. So remember that vulcanized rubber can be prepared by natural rubber by incorporating the sulfur. Next, synthetic rubber. Synthetic rubber we can prepare in laboratory. Natural rubber is we can get from latex of different trees. Now, natural rubber there is some limitation. So if we can perform some process that is called vulcanization process, we can getting vulcanized rubber. Another type of rubber is synthetic rubber. Synthetic rubber, it's not obtained from nature. It is synthetic. Synthetic means we get this rubber by some chemical reaction. For example, this is called this is not condensation, this is called copolymerization reaction. So if we perform copolymerization reaction between butadiene and styrene, we'll get one synthetic rubber called butadiene bu and styrene S. Okay, so it is called butadiene plus styrene. We are getting Buna S. So Buna S is a synthetic rubber. This is also called government rubber or GR. Okay, so Buna S is a synthetic rubber which is being prepared by reaction with butadiene and styrene. It is also called government rubber or GR. Okay, next one, another is Buna N. Now butadiene, and if instead of styrene, if we use acrylonitrile, this is called acrylonitrile, we'll get another rubber that is called uh, Buna N. Buna means butadiene and N acrylonitrile, so called Buna N. It is called GRA rubber. Now, if we use chloroprene molecule, it's a monomer unit, and perform the polymerization reaction, we'll get the we'll get polychloroprene, or it is also called neoprene. It is also one type of rubber, GRM rubber, right? So there are three different type of rubber. Synthetic rubber, I discussed. One is GR rubber, butadiene and styrene. Then GRA rubber, butadiene and acrylonitrile, and GRM rubber, that is chloroprene. Chloroprene is a starting monomer unit. Okay, so these are the